Record. Okay, so hello everyone. I'm gonna turn my video off so I can stop staring at my own face. Okay, so this week, uh, let's see, Rich last left off at chapter 8. So we're gonna try to finish off chapter 8 and continue on to chapter 9. So here we go. So the last session was list nesting. So we're gonna move on to list slicing. Okay, rearrange. Okay, so list slicing, the slice notation is sort of a shorthand uh, way to retrieve elements from a list, right? So you could see in the first example here, you have a list with 3 elements, and the first print is using the slice notation 0 and 2. So what that's doing is it's getting the element 0 and the element 1. So the 2, so it always starts at the first number and 1 less than the last number. So that's normally how things are done with these zero-based arrays. So 02 will print the first 2 names, Tyler and Dedno. And then 1 and 3 is starting at 1 and then 3 minus 1, which will be uh, the element 2, which is Patrice. Okay. So for this one, let's just move on to the challenge activity here. Okay, so in this challenge, we have a new list of numbers there, and we'll see the notation 0:4, what that'll print, right? So one way you can look at it, if it starts with a 0 and the second number is a 4, then there should be 4 elements that you're printing. So it's 4 minus 1, which is 3. So it's 0, 1, 2, and 3. So this should be the first 4 elements of the list. So it should be 13, 14, 15, 16. All right, let's check. Ah, okay. So it's doing a very literal check. So it needs the spaces and the carriage return. So we'll try again. So this time it's changed it to 02. So it should be 13, 14, enter. We'll check. Oh, okay. I put an extra comma. Okay. So 13, 14. Oh, I need the okay, let's see. There we go. Yeah, I also forgot the braces. Very good.
You can, with your version, you can actually skip and like go to the third one. What I do is I do the first one, the third one, the fifth one, whatever, and then I leave 2 and 4 to them or something, just, I kind of mix it up like that. You can do that, they cannot. And in fact, they can't actually go now to number 3 and do it with you. So that's something to remember. If you could do them in order, then they can do them with you, but sometimes it's not.
Yeah,
such a bad. You skip it, and then they have to watch you, and then when they get to. But you're making a video, so they.
yeah. Okay. So I think we'll just do number 3 here. So, you can see it's kind of repetitive what it's doing here. So in this case, this one's not starting with a 0, so it's going to start at 14, right? And don't forget the bracket. So it's going to go to, so it's sort of like you can look, 5 minus 1 is 4, so there should be 4 elements. Okay, check. All right, so we got that right. All right, let's go to the next challenge activity. Okay, so list destinations list is read from the input. Assign selected destinations with a slice of destinations list from the second element up to and including the last and excluding the last 2 elements. Okay, so this this is a good challenge. So the other part of the slice notation is the relative uh, indexing. So let's go back up to see where they explain that. Okay, here we go. So position of -1 refers to the last element of the list. Okay, so this is handy if you don't know the exact size of the list, or the list size, shrinks and grows. So if you know you want the last element, then its position is -1. Okay. So again, in the here they're explaining if you want everything but the last one, -1 represents the last one, so it's always the one previous to that. So -1 will give you everything but the last one. Okay, so let's go back to the challenge here. Okay, so I'm gonna read it again. List destinations list is read from input. Assign selected destinate with a slice of that list from the second element up to and excluding the last 2 elements. Okay, so we want selected destinations equals. So we're going to take a slice of destinations list. So if we want the starting from the second element, that's going to be a 1. Right? 0 is always the first element. And we want up to and excluding the last 2. So if we did a -2, if you recall, a -1 excluded the last element. So if we want to exclude one more, we'll do a -2. Okay. All right. So let's check that. Okay. So all the unit tests have passed. So we're good to go there. Okay. So now let's move on to loops modifying lists. Okay. So sometimes program iterates over a list while modifying the elements. Okay. Which can be changing the values or moving list elements around. The below example of changing elements values combines the length and range functions to iterate over a list and increment each element by 5. Okay, so what this is doing is it's doing a for loop. So it's getting the range based on the length of my list. Right? And then that ith element, it's adding 5 to each element. Okay. Okay, so let's look at this is a good example of a common error that can happen. Okay, so in the correct way, you're doing it like the above example where you're getting a range, and that's basically going to give you 0 through the end position index, and it's saying you need to do that to get the actual value of it, and we're checking that it's negative. So if it's negative, then you're reassigning the value of the list element at position to 0. Okay. In this case, uh, you can iterate over a list automatically like this, but what you're getting uh, in num, you're not getting the list element, you're just getting the value returned. And when you set it to 0, you're not changing anything in the actual list. Right? So this is a good shortcut if you're just reading over the list and you're not modifying it. Okay. So let's look at the first challenge. So we'll start this. Okay, user value is 269. So for the range, we're just doing a simple print. So this should give you, let's see, this should give you 2. So now you're not printing a list, you're just printing the numbers returned. So I believe you should just be getting that. But let's see. Oops. Oh, all right. Can't reach their servers. Let's try again. Let's make sure I'm on, my Wi-Fi didn't time out. Let's see. Let's try again. Let's try refresh La Lima. Okay, looks like we have internet. Okay, this looks like it's a technology issue at Zybooks. Let me try refresh the page. Start. Okay, there we go. Yep. So that was right. So this print is no longer printing a list, it's just printing a number. So a normal print just puts the number on a line. Okay, we'll just peek at the next one, but I think it's sort of the same. Okay, since we're here, all this is doing is it's going through every element in the list and it's incrementing some value with every number from the list. So there should be 3 plus 4 plus 7, which is 14. Okay. So this is an example. Uh, since we're not modifying the list, this is where you can use this other notation here, right? Okay. Okay, a common error is to add or remove a list element while iterating over that list. Such list modification can lead to unexpected behavior if the programmer is not careful. Okay. So consider the following program that reads in 2 sets of numbers and attempts to find numbers in the first Oh, my zoom is covering that up. Sorry. Set that are not in the second set. See, there we go. Oh no. Okay, that's better. I was trying to hide my zoom control. Okay, so let's see what this program is doing. So the above example iterates over nums1. Okay, nums1 is a list, nums2 is a list. Tokens. Okay, tokens is a user input. Okay, for in nums1 dot append int val. Okay, so the tokens that's inputted by the user is put into nums1. Okay, so you see the output here. The user inputs a second set of numbers, and this time it's getting put into nums2, shown here. Okay, so remove elements from nums1 if also in nums2. Okay, so what's happening here is for deleting val nums dot remove val. Okay, so we have 5, 10, 15, 20. So what we expect is that 15 and 20 should be removed from nums1, right? But only 15 is being removed, right? So the reason for that is let's see. So as it's iterating from nums1, if val in nums2, so checks 5, it checks 10, it checks 15. 15 is in nums2, so it removes it. So now you're removing something from nums1 that you're iterating over, right? So there's probably an exact way Python handles it, but logically it doesn't make sense now, right? So if it goes to the next index after, because 15 is now removed, there's no 20. It probably just skips 20, which is why it's not removing 20 here. Okay. So here, so there's a simple fix to the problem. So it's to iterate over a copy of the list instead of the actual list being modified. So there's a special notation to copy that way. Okay. So let's move on to a challenge. Okay. So satellite signals contains integers read from input. Each integer represents a signal received by an antenna. Write a loop to update all elements greater than 110 in satellite signals with 110. Okay. So here we go. So the input is handled for you here. It's printing the original signals. And now your code goes here. So it's going to print the end result. So this is where we're gonna iterate over that list. So we have a handy example up here. So let's see if we can just cut and paste to save some time. Yeah.
So Ria, can you come in tomorrow a little bit early, like 11:30? What time your class finish? Tomorrow, 11:30. Okay, yeah, I have a 1 o'clock meeting. Thank you. Okay, 11:30. Thank you, Mr. Young. Thank you.
Okay. Okay, I'm gonna resume. All right, so let's see if we can just copy what we got up here, which will be similar to this solution here. Okay. So we're going to cap all the values to 110. We want the list is satellite signals instead of nums. And we're going to go through the entire range of positions. So now if it's greater than 110, we're going to set it to 110. Oops. Okay. Let's check it. Okay, so it passed, right? All right, so now let's move on to see list comprehensions. Okay, so let's skip this one. So this is another notation to uh, help with shortcutting. Let's move on to sorting lists. So one of the most useful list methods is sort. So it performs an in-place rearranging of the list elements. Okay, so normal rules are followed by default. Then there's another thing you can do where you can, instead of doing an in-place sort, you can get a copy of the list sorted and assign it to a new list so that you can preserve the original. So that's another useful thing to do. Okay, so both of these have an optional key argument. So this specifies a function to be applied to each element prior to being compared. Right, so examples of key functions, things like string lower, string upper, string capitalize. So you may want to sort some names. In ASCII, the capitals letters are always first, but you may not want to sort it that way. You may want it logically so that you apply, let's say, string upper to everything so that it still sorts alphabetically. So basically in a case insensitive way. So yeah, so it's showing here the capitals come first before J and R. But with the key, where they're doing a string dot lower, then it's sorting it in a case insensitive way. Okay, so moving on. So is list sorted? This is a lab, so I'll leave this to you guys. Skip that. And we're gonna move on to, let's see what command line args are. RB. Oh, okay. So I'll just go over this one quickly. So if you're running a Python uh, program from the command line, you can feed command line arguments, and basically what it does is it puts it all into I believe it's a list. Yeah, sys.argv, which is a list. So they're showing you here now that you know how a list works, that that's how you can get command line arguments. So if you're executing your Python command like this, myprog trisha 12, so argv, uh, you see this is element one is going to be trisha. So element zero is actually going to be this right here, the name of your program. And then so forth. So if you had more arguments, then that list would just be bigger. So argv0 can be useful to know which program was executed. Here it's showing you that so if you did write a Python program and you wanted name and age input, you can do some checking to say, hey, if the size of sysargv is not 3, then something's wrong, and then it's printing a message telling them how to use it and exits. So that's like initial error checking. Error checking is a key thing when you're programming. So this is a way where you're not going to get an error way down the line with your program. You're helping the user right away to tell them that there should be two arguments, name and age, right? And then further down, you might want to do typically you would error check to make sure that age is a number, and also uh, reject that and maybe show the user a message saying the age should be a number. Okay, so let's see what this is. Additional practice engineering examples. Okay, so I will leave this to you guys and move on to dictionaries. Okay, so let's see what a dictionary is. It's another type of container that is different from sequences such as strings, tuples, and lists. Dictionaries contain references to objects as key value pairs. Each key is associated with a value. Okay. Uh, so in some languages, this is called an associative array. It's basically, yeah, like they say, it's just a list of keys and values. Okay. Let's see. Well, let's look at this one real quick. Keys are Bobby, Allen, 10, and then you have the values, and they can be of any type. Okay, let's look at an example of how we're gonna do. let's look at this example here. Okay, so we start with an empty dictionary. Enter a name and grade. Enter a name to delete. And then a menu item, add, modify, delete, print, and quit. Okay, so if starting with the empty dictionary, if the user inputs one, which is to add or modify a student grade, we're taking the name and the grade, and we're using the name as the key and assigning a grade to it. And it's add modify because what will happen is if the name doesn't exist, a new dictionary entry will be created. If the name already exists, the the basically the key is preserved. It doesn't make a second copy of the key and just modifies the value, which is the grade for that key. Okay. And if we're doing a delete with a number two, then it's gonna delete the the name key, right? Three is print student grade, so it's gonna print out the entire dictionary, and four is to quit. So let's look at, let me see if I can make this bigger. There we go. Okay, so we're gonna add Bob A plus, Aria A minus, Conor Jordan. Okay. In this case, there's no overriding. We're adding four new keys, right? Then I think three was to print. Yeah. Then we're printing it out. Then we're doing a delete and we're going to delete Bob. And then we're going to print it out again. Okay. So let's see what that looks like. Okay. So it's going to print the prompt several times, right? And then at the end, it's showing you the four different grades, right? Then we're doing the delete, and the delete was Bob. So in the last print, there's no more Bob. Okay, so let's see how many challenges we got. Okay, let's do the first one. So type the output. So we have a new dictionary. We're assigning three key values to it. And we're going to print the airport codes of two of them. So Minneapolis, it's MSP. Okay, and then Amsterdam, AMS. Okay, let's check that. Okay, there we go. Put on. Okay, so this is just a good reference of all the different things you can do with the dictionary. Let's see what else we got. Nesting and iteration. Okay. That's okay. So iterating over a dictionary. So let's look at this for loop. So for key in dictionary statement six. So the most natural way to iterate over a dictionary is to iterate over all the keys that's in there. So you can use items to go through all the items, keys, or you can go over the values. Okay. So I'm gonna skip over this. So all of this is similar to how a list works, including when you get to uh, nested dictionaries. The difference is that they're key value pairs and the keys are unique, right? So when you're using a dictionary, it's usually when you have a when the important part is that the keys are unique and everything is associated with that key. So it works for things like people. Okay. And when you're nesting, uh, so it's similar to nesting lists. You can have another. You wouldn't have it in you wouldn't nest it in the key side, but in the value side, right? So you could have something like uh, you can have your grades. So the first key would be the student, and a value can be another dictionary with key value pairs of the course and grade. Okay. So now we'll move on to chapter 9. Then we can get a little more caught up here. Okay, so chapter 9, classes. Classes is this is a very important topic. If you take the next course, ITS 148, you actually repeat, you start with chapter 9 typically again to review because classes is very important in programming. Okay, so let's see. So I'm not going to read all of this. Let's skip over to a challenge activity. Let's see. Okay. So there's sort of two ways you can try to learn things. You can try to read all the chapters ahead of time, but sometimes you just want to get to the problem and then go back up to figure it out, right? So let's go look for the first challenge and then go back. Okay, let's start with the first challenge here. Okay, so we have a class person, and basically the person just has a name element here. So we're creating a new person. Username is Ron, right? That doesn't do anything with the class yet until you assign person one's dot name with the value of username. And now we're doing a print I am person one dot name. So this should be I am Ron. Oops. Check. Okay, so that checks out. Probably, okay, let's skip this and move on to, okay, this is a good one. Okay, so create an instance of student data class called student, then read 3 values from input into students' attributes in the following order: birthplace, credit hours, and age. So the class is already made for you. student data, okay, and then that's gonna print it. So what we want to do is we just want to get the user input of these three things and assign the values. So order. Okay. So okay, first we have to create a new student. So let's come back here. How did we create one? Okay. So we created person one by just doing that. Do that. So that's going to create instantiate, it'll make an instance of student data. Oops. Okay. Student, gonna have three, so birthplace. So that's without any checking, we're just taking the inputs. Let's see how that goes. Wow, okay. So we need to read that as an integer because by default it's read as a string. Okay. So um, so reading that as an integer was something previous. So instead of hunting for it, I'll just peek at the instructor solution. So all it is we're doing int like that. Okay. So of course you don't get that, of course. So in this case, what we're doing is we're just casting to an integer. So so this works fine if the user entered an integer, right? If they didn't enter an integer, you'd get an error. So in a real program, you'd probably take the string, uh, check that it can be converted to an integer, and if it's not, print some sort of error. But in this case, we're just doing a simple example, right? So now we're fine. But as you can see in the unit test, there was no uh, string given in there. So when you write real unit tests for a program, you would put you would always put input that's invalid to make sure that the program handles it properly. Okay. So instance methods. Okay. A function defined within a class is known as an instance method. Okay. So a class outside of just grouping values together logically, you can also group functionality code together inside the class. Okay. So in this first example here, there's a time class, and then there's a print time function that's being created. So this is where in your class, print functions are common in classes because for that given class, you want to format that print a certain way consistently. Okay. Right. It's so we're saying, okay, we want to print it as hours, 7 minutes, 15, right? That's that's probably not how you would want to print a time, but basically in the function, you can define it however you want to print it, right? And and there's no new line because of that, and that's why it prints it all in one line. Okay. So again, let's jump to the next challenge. Okay. Start this one. So rectangle, rect1 and 2 are instances of rectangles. Okay, length and value list. Define instance method, print attributes to output the following in one line: length, and then width, and then the values. Okay. So this is going to be very similar to that first example of the time. Okay. Here. Okay. So let's copy that. Oh, here I am. Okay. Okay. So instead of print time, we're going to do print attributes. Get rid of that. Okay. And then print F. We're going to do length, colon, space, and we're going to do self dot length. And we're going to keep that so that it doesn't put a new line, right? Should all be in one line. And then width. So it's that, comma, and there should be a comma. Is there a space there? Yeah, there's a space. Oops. Comma, space, width. Okay, let's give that a try. Okay, something doesn't work. Okay, so there's an extra space before the comma. So let's see. It. Okay, so now it's happy. There's no extra space. So we got class and instance object types. Sir. Okay, we got 20 more minutes to go. Okay, a program with user-defined classes contain two additional types: class objects and instance objects. Okay, a class object acts as a factory that creates instance objects. When created by a class object, an instance object is initialized via the init method. Okay, the following tool demonstrates how the init method of the time class is utilized to initialize two time instance objects. Okay, so the init, so basically in the init method, it's setting the hours and the minutes to zeros. Okay, so let's see if we can just skip down to a challenge on that. Okay, so in this case, in the init method, self.color is set to none. Okay, so we're making two shapes, shape one, shape two, and shape two's color is set to orange. Okay, so shape one's color is set to none. So I think that'll be just blank. And shape two will be orange. Let's see what that's like. No, it's actually gonna print none. Okay, so we know it's gonna print none. Then let's do the first challenge here. So define a class attribute mginfo in weight class and assign mginfo with milligrams. Example, if the input is 18, then the output is 18 milligrams. So mginfo. Oh, I see. Okay. Now class attributes. Print that, then print that. So it's instance. So this. Let's see. Is it going to be this simple? No, that's wrong. Okay. So what we need to do is figure out what a class attribute is. Oh, so here's a class attribute. So it's different from a value. So should not be a self there. Okay, so now we're good. Okay, so let's go back and just look at the attribute again. Instance. Okay. So an instance attribute is unique to each instance. And that has the self dot notation. Okay. And then class attributes. Right. You're placing a constant in the class scope. So basically this is a constant that no matter what, it's in the class definition. So any instance of this class will always have this as a constant. Let's see, seat reservation system. Let's see. Let's move on to constructors. Okay, a class instance is initialized to a specific state. The init method can be customized. Okay. So here's an example. When you create the class, so far we've been doing it just with the empty braces, but you can pass arguments to the constructor when you create the class. So instead of race time and just empty braces, you can feed the three elements, right? The self is implied. So if you didn't have any, you would still have self and empty braces. So you have three arguments here, three parameters, and that's what that's what you're passing into the constructor immediately. So this is not any different uh from making an instance with empty parens and then assigning the start time, end time, distance separately, like we have been doing earlier. So this allows you to have a shortcut, right? So we can see here. So this constructor has many parameters, and let's see, print time, pace. Yeah, so we can get all the inputs, and then we can do it in one line. And then you can also have constructor defaults. So in this case, we're defaulting wage and hours. So that means if, let's see here, if we just provide name without wage and hours, it's going to default that. But if we do supply wage and hours, then it's going to override that. So these are all just shorthand ways to set up the class. It's really no different. You know, you can again have an empty constructor. You can you can set the instance attribute for wage to start at 8.25, you know, so you can do all of that, but these are good shorthand ways uh, for coding. Okay, so we'll skip the challenge here and let's see. Okay, interfaces. Class interface consists of the methods that a programmer calls to modify or access, create, modify, or access a class instance. Okay. So this is a class to inner instance. Let's see. I think they're just sort of glossing over the interface here. I think I'm trying to find a good way to explain it. Okay, well let's look at this piece of code here. So interfaces is a slightly more advanced topic in classes. Kernel usage and definitions highlighted. Okay. Yeah, on the surface, this just looks like a normal class with class methods and a constructor. Eh, So it looks like in Python, the interface is more by convention. Okay, so I don't want to confuse with interfaces. Uh, so this is sort of just an introduction of the concept. There's not even a challenge activity here, right? So I would say just read through this, but don't get hung up on it yet. The interfaces in classes is it's a it's a concept. In other programming languages, it's more formalized. It looks like in Python, it's not really. Yeah. So I would say don't get hung up on this for now. Let's see. Okay, class customization. So yeah, this is also one. Let's see if there's a challenge for this. Okay, this one does have a challenge, but um, earlier we showed how you might want to define a print function for the class so that you print consistently, right? In that example, you had to call the class function called print time. Okay. So what you can also do is you can also override some of the default behaviors. So if you did here, right? So if you called print time earlier, print time is a function that did a bunch of print statements, right? But if you override the string function, what that does is anything in Python that wants a string form of your instance, that's what you're overriding, right? So if you didn't override it, it's showing right here that if you did print truck, this is Python's default way to show that instance. So it's just showing you the path to that instance and the instance ID, right? So if you override that, but what you're doing is you're going to return a string that you define how you want that formatted, so that now if you do a print truck, right, this print function is looking for the string version of this object, and it's overridden here, so it's going to follow that code, and that's why it gives you that. Okay, so let's look at the challenge. Okay, so we're gonna skip this, but it's basically telling you to write a string method to match this example here. Okay. Okay, and then this is operator overloading for classes as numeric types. So you can, so this is more changing default behavior. So, in this example, you, you have you're overriding the string here, and this is greater than. You can override how greater than works. So if you had an object and let's say you're sorting it, when you're sorting numbers, it's straightforward. If you're sorting classes, uh, this is where you can define how to determine what is greater than the other, right? So uh, in this case, we have hours and minutes, right? So we're overriding greater than self to something else, right? So is other greater than myself? So now you have two numbers, so you have a more complex function. So if it's actually, oh, is self greater than the other? That's what we're doing. So if the hours is greater, we don't care what the minutes is, we're greater. So you return true right away. Okay. Otherwise, the hours are either less or equal. That's what's left over. So we're saying, okay, if hours are equal, then you check the minutes, and if my minutes are greater, then I'm greater. In all other cases, I'm less, so we return a false. Right? This is overriding subtraction. So same thing. When you're subtracting time, hours, and minutes, you have to do some math. You take away some hours, and then you have to check against. So you do a bunch of logic to return sub the correct subtracted time. Okay. Okay, memory allocation, garbage collection. This is just telling you what Python is doing. This is totally transparent to you, so you don't really have to do anything about it. But this is uh, just telling you how Python handles it. A lot of different programming languages handle it different. Most modern languages handle it how Python does it, where you don't have to worry about it. So this is just an explanation. So, okay, so now that got us to the end of the class. Any questions?
Gotcha.
Okay.
If you have questions, you can email either me or again.
Yeah, you can email either of us. So I'm gonna try to write something up on interfaces, right, as it relates to other languages. Just to give you background, but it's not something you really have to worry about. I'm gonna stop the share, and I'm gonna stop the recording.